There are over 3 million ATMs around the world. Just imagine that attackers can get only $1 per hour from each ATM. Attacker can earn over 3 million per hour. Is anyone of you have the same salary? I think no. We would like to talk about several ways which attacker or some bad guys could use to eject money from ATMs, but don't use this way because it's illegal. It's just for your knowledge, just for your understanding that ATMs is not so secure. It's really illegal, and I think especially in Singapore. So, time to say hello. I'm Olga Kochetova, and he is my colleague Alexey Osipov. We are from Kaspersky Lab, and as a part of Kaspersky Lab, we provide several security services for various industries, such as ATM and post-security assessment, penetration testing, forensic investigation, and other. And other point of our knowledge about ATMs, it's our test bed with several ATMs from major vendors, where we do our researches. So let me speak about ATM in general, just several words for your understanding. ATMs like Lego for big boys, for adults. Big vendors just take hardware units produced by various manufacturers and put it together and call it ATM with brand blah blah blah. The top box of ATMs called service zone or cabinet. There are PC, touch screen or simple monitor, card reader, pin pad, and so on. All hardware units connected to PC through serial or USB ports. Vendor thinks that service zone is not important and produce cover from plastic with single lock. Very simple and even the same for various banks. The bottom part of ATMs, it's a safe, where consists of dispenser and some could consist some device for cash-in. Typical dispenser consists of for cash cassettes and one cassette for ejected notes. Each cassette can contain up to 3,000 banknotes, so attacker can get with one attack up to $15 million or euros. What about soft? There are Microsoft Windows as operating system, main application which provide graphic user interface for interaction with customers or with engineers, and other part of this software control the device and communicate with processing center. There are also some antiviruses or integrity control systems or video surveillance, and some banks use really unused software, and some of them gives attacker unlimited control to device, to ATM. Devices are unclear. There are some strange microcontrollers with real-time operating system, and guys who loves either Pro very sad about it. How it works? Processing center through the network send commands to ATM, to main ATM application, and the part of ATM main application translate this command to hardware units through the XFS manager and through the service providers. XFS, it's standard, was developed by Microsoft in 1991, and it's a secret why a lot of ATMs run on Windows. And it's not a joke, Windows XP still alive, despite the fact that Microsoft stopped to support this operating system more than 2 years ago. And it's not secret that if some vulnerabilities would be found, they won't be patched ever.
But let's give some words about what the communications of the ATMs, because ATM machines can't decide what to do on their own. Network is pretty much obvious. We have different ATMs on the slide that is connected to processing center, for example, with wireless connection, wired connection, with protection or not, and so on. Wired connections are pretty much obvious. It's cable modems, telephone modems, Ethernet cables, and so on. But that's not interesting. The interesting part that many ATMs are connected via wireless connections, pretty much the same as the PLCs, for example, in different SCADA systems, in different trains, they intercommunicate with each other through the GSM networks. After the connection to the processing center, the data is decoded and the commands are sent to the ATM machine. But what are the wireless connections? It's obvious that there are different evolutions of the same standards. Previously we had CDMA that is pretty much dead now, but maybe existent in some countries. Then we have GPRS or Edge, and newer ones like UMTS or LTE. All these standards has some security measures inside. For example, they provide encryption of data, integrity controls, and so on. But what is often forgotten that CDMA, for example, is commercially broken. There are different companies around the world who provide their customers with the industrial-grade solutions for CDMA interception. 5,000 euros, and you can buy the device that will intercept all the data inside in about 100 meters. GSM is broken by enthusiasts, but not only enthusiasts, but also government, different big agencies, and so on. If you want to get into the GSM connection, you can just buy the special telephone in about €5 and intercept some data that is going over the air. But as for UMTS and LTE, there are no industrial solutions, but there are state-of-the-art research that gives us knowledge that not everything good inside these standards. One can approach it, one can intercept data, modify it with different problems, with different obstacles, but actually it's feasible. Obviously, this data should be protected, and banks don't want to lose money. They use virtual private networks, and they're also obvious. You can have software, hardware, and the most good for me and for many banks, they don't want to use at all. They just connect into some IP address and port in the internet and transmit all the data in clear text. Hardware VPN servers has different good qualities. Actually, they have a built-in firewall. If you scan the internet, you won't connect to the ATM machine. You will connect to this VPN client. And thus, you can conduct, for example, MS08067 vulnerability in Windows XP to execute any code on this ATM machine. It works regardless of the computer of the ATM machine. So if you manage to access the ATM machine, you won't access this VPN client. And actually, it's metal and plastic. You can grab it with your own hand. But there is a catch. If you can grab anything with your hand, and if it works regardless of the computer, you can just open ATM machine, get this VPN client, go anywhere else, and connect to the ATM network of this bank. Pretty obvious, and actually it's really happening. And so it doesn't protect you against physical access to the ATM machine, but on it later. Software is much cheaper. You don't have to have service engineers that will go to the distant ATM machines, install this hardware, and so on. So it's easy to deploy. But there's always a catch. Many of you might have seen this windows on the ATM machines where VPN connection is broken and the data is transmitted actually in clear text. And the attacker with bad intentions can actually break this connection with, for example, ethercap, bettercap, and so on, and connect to the ATM machine There is something that banks don't understand. With software VPN, you should have firewalls, because if someone can connect to your precious ATM machines with your money, they can dispense them. If you have hardware VPN server, you should protect better with physical security. And always you should know that knowledge about your good qualities and bad qualities is important. But when we can connect to the ATM machine, what we should do?
So the most interesting things, I think it's joke about ATMs when we hear every time that bank guys say that there are no ATMs around the world in the internet. But they should open their eyes, because we have Shodan or other internet scanner, and we can use the secret words and find thousands of ATMs around the world which are online. We can find some information about these ATMs, such as IP addresses, vulnerable services, and in some cases we can find even physical address of these ATMs. And surely attacker can use this information to have money, have easy money. In case of unprotected networks, attacker can connect to this network some devices and send commands to ATM to eject money instead of a real processing center. Sometimes attacker could use processing center emulators. It's other gifts from ATM vendors. These tools allow possibility to check security or network settings by sending dispense commands. But attacker use it as instead of real processing center to eject money, and there are no checks. Other kind of attacks, when attacker can connect some device to the network or to the Ethernet cable and send commands to this device consists of a piece of software which emulate a real processing center. And on the slide we can see a typical log with several dispensing commands, and in the green part there are dispense for 40 banknotes from 4 cassettes. So there are several demos which we provided in our test beds. In this video you can see through the wall ATM with network equipment outside of it. Attacker disconnects ATM Ethernet cable from network equipment and wait when ATMs became offline. So ATM is off, and now attacker connects ATM Ethernet cable to specially crafted device. In our case, it's a Raspberry Pi. So now ATM became online and controlled our piece of software which emulate processing center. Now we can use any cards. And any pins. And it looks like original transactions, but sometimes we can add some additional screens, and we can choose cassettes to eject money. Really slow ATM because it's old. And now we have money. And also we can print any information on the receipt.
And the important thing is that there is no exploitation of any vulnerabilities, any code executions on ATM machine. We just connect our device instead of the original processing center and send the commands. How it's possible? It's possible because of protocols that are used by ATM vendors, ATM machines, to conduct transactions. And the family of such protocols called direct connect protocols. There are different opportunities for legitimate use. With this protocol, customization data is sent. For example, the state machine, which screen will be shown, which data will be shown on the screen, and so on. It's go in or out of service. For example, if bank don't want to use this ATM in night, for example, he can disable it from the connections. Banks can get abnormal statuses, for example, with the jam in the dispenser, with different problems with its devices, and send the service engineer to see what's actually happening. And the most important for us is transaction response. For attacker, only transaction matters. And as you can see on the slide, the protocol is actually text-based. You just can modify one byte of data and get, instead of $1, for example, 10, and so on. Yes, there is opportunity for security. There are internal mechanisms. Instead of VPN connection, you can use SSL TLS and use MAC protection. SSL TLS protects the integrity of data and the confidentiality. And MAC protection protects against the modification of data, but all the data transmitted in clear text. Unfortunately, what we see in the real life, SSL TLS is not implemented because there are different problems with the certificates, with the service engineers who don't want to go to ATM to install them, and so on and so on. So there is no encryption in the standard. MAC protection is complex. When the service engineer enables the features, he actually doing the thing 22, then some obscure number that will protect the data. If he managed to make a mistake, and all people do make mistakes, the MAC will be added to the message, but it won't be checked. Pretty much strange, but it's actually happening. And server and client may have different configurations. And if they have different configuration, then ATM won't work. It's money, and banks don't want to lose money. And when we speak about networks, it's also much more complex. There are different administrators who want to manage the ATMs. There is office computers that should be separated from the ATM machines, but in many cases they are not. And if you have some background in hacking, compromising one machine in the large domain can lead you to the ATM administrators and lead you to processing center, and then you can send all the comments instead of legitimate. And administrators are lazy. They want to have one point from which they will control all the ATM machines. And what is more good for them if they can connect all ATM machines with each other, not ATM to the controlling machine, but any to any. And when we can compromise one single machine that is located, for example, in the lobby of this hotel or anywhere else, we can compromise all other machines, and there will be no forensic evidence on them. And you should understand that VPN connections that are protecting data are not protecting logical access to the ATMs. Yes, the data is transmitted securely, but they all are in the same broadcast domain. And here's the video that is pretty much similar to the previous one, but we have 4 ATM machines, and we have key only for one of them. We open in the service zone, disconnecting Ethernet cable, but we're not connecting it to the we're not connecting to the ATM machine. We're connecting to the network of the ATM machines. The very same Raspberry Pi is left inside. From the outer point of view of the bank, they see that ATM is gone offline. There is plenty of ATMs without alarms, for example, or different problems. And here we are sending the customization data that changes the screens on the ATM machines. Then friends of the attacker goes to such compromised ATM machines and dispense all the money from them. One after one. Here's our jackpot, and you should understand that we can actually get all the money from such an ATM. And to be more evil, we are returning to the previous ATM machine, disabling our hardware, and leaving service engineers to break their heads how it's possible and how the attacker did such a thing.
So as we can see on the video, sometimes attacker need to be inside of ATMs, inside the service zone. And as I already mentioned, a lot of vendors produced their ATMs with simple and single log for all ATMs. And of course, we can find it in the internet. We can find the keys from ATM's cabinet or service zone, or if we know the code of key, we can tell locksmith to code it and get it cut. But sometimes we can ask some friends with special tool to open the door. This video. This event was happened several years ago on Positive Hack Days conference, which placed in Moscow. And this guy see this ATM from this side the first time, and he need only 1 minute to open the door. Usually, bank guys say that they use alarm systems, but it will be no alarms until ATM's door is open. So, but sometimes we don't need to open the door. We just need to look around and find a lot of ATMs with USB or Ethernet cable placed outside, or network equipment placed outside, or even sometimes we can find a lot of ATMs with open doors. And the pretty much interesting story when we hear at least one time per month when guys came to ATM and find it empty. They on video surveillance they can see that some guy came to ATM, opened the service zone, placed some large box inside the ATMs, and leaves. And after that, other guys came to ATM and just eject all money from ATMs and put it in their backpacks. So no money, no logs. And for bank guys, it looks like a magic, but it's really easy as a pie, because attacker connect special crafted device to dispenser instead of host. As I already mentioned, all hardware units connected to PC through serial or USB ports, and in this case, attacker can connect some device to USB dispenser cable directly and send commands instead of host. For example, with a card reader, attacker can intercept all track 2 data from Xtripe in plain text and produce the fake cards to dispense all money, to withdraw all money. And in some cases, attacker can intercept transaction history data from EMV chip, and this data is enough for card not present transactions. And on the slide, we can see comments and intercepted track 2 in plain text. And even sometimes attacker don't need to do something, they just need to find some USB sniffing software in the internet, install it on the ATM, and collect all track 2 data for many years. And what we can do with dispenser, we can see on this video.
Attacker opens the service zone of ATM, and ATM goes to the supervisor mode. We see that all devices are connected on the screen. Then we use our Raspberry Pi, disconnect the USB cable from the ATM machine, and on the screen of the ATM, the dispenser goes offline. We connect this USB cable to Raspberry Pi and close the service zone. And don't forget to disable supervisor mode. Now the attacker can send the commands via Wi-Fi or Bluetooth connection, just pressing the button on the mobile phone and getting money from the ATM machine. But that's not something that we haven't spoke about. It's already there for many years. When we spoke about REST 232 connections, the bank guys said, oh, okay, we're using USB connection, so we're safe. Unfortunately, that's not the case. You saw on our videos plenty of means to dispense money to gather the track2 data of the customers. And most of these attacks have only 2 minutes to install and to withdraw money. It's pretty scary, and unfortunately, the banks don't believe in such things. And why it's possible? It's possible because of trust zone. Trust zone in ATM is very vast. For example, in the secure devices, no one should trust anyone besides after authentication and encryption of the data. The data should be authenticated, and all the packets should be controlled. But in real life, unfortunately, it's not the case. ATM machines in their networks see each other. ATM machine itself can send commands to the dispenser unit and withdraw money without any connection to the processing center. Processing center can send data over unencrypted channels and don't have possibility to control authenticity of this data. And in many cases, the MAC authentication is actually enabled, but unfortunately it doesn't provide confidentiality. All the data transmitted in such a way are gathered by the attackers, and they can then they can create the clone of your cards without any knowledge from you. And customer, when he goes to the ATM machine, have no possibility to know whether this ATM is compromised and whether it's safe to insert this card. With trivial schemers, one can see, oh, okay, I see glue on the card reader, so I won't insert my card here. But with the software attacks, unfortunately, you can't do so. Yes, it's dangerous to go alone, and many banks, when they face the problems with their systems, are like this kitten. They don't know what to do, they try to do everything, and actually they're only making the things worse. What banks actually should do? They should enable all security options that are already there. ATM vendors want money, yes, but also they want customers. And if they advise you to use some security measures and protection and so on, you should enable it. But many vendors are not that good. And in many cases, they say, okay, you have a problem, then you should pay me money. You can go to other vendors, you can force them, because when such cases became very popular among the criminals, many banks can force the vendor to fix such vulnerabilities. Compliance, unfortunately, doesn't guarantee security, and it's a thing that should be mentioned every time and every time, because in many cases we approach banks that say, okay, we are PCI DSS compliant, but unfortunately ATM machines are not in the scope. We say, how so? And they say, okay, we're just paying some more money for the people who conduct penetration tests. And don't forget that predictive analysis is much better than forensics. When you do forensic analysis, you already lost some money and you lost some reputation, because such cases became widespread, and it's understandable among the security professionals. Don't forget that bad guys are watching you. And if you don't want to do anything, then you should have plan B, like that kitten. Disable all ATMs, move them in secure locations, for example, in the bunker, I don't know, and lose money. Thanks for all people who helped us with our presentation. Without their reverse engineering skills, without their knowledge, it won't be possible. And if you have any questions, then please ask. Thank you for your attention.
No question?
Okay.
Thank you.